Now let's find the limit by using algebraic techniques. In this case, in this particular example over here, we'll use conjugates, algebraic conjugates. So, and this is a very common technique that you'll use, like even me as an engineering major, I use this a lot. So it says that we have to find the limit of this function here as h approaches 0. Now initially when you input 0 in place of h over here, you get 0 over 0, and that is undefined. So you have to find another way to find the true limit of this function, and that's by simplifying it. But this is a very complex case over here. How do you simplify this? You can't find any typical algebraic identity to apply over here. Nothing is being cancelled out in the numerator and denominator. So what do? You multiply the numerator with its conjugate, and you divide it also by its conjugate. So basically this entire term here over here, right, this is equal to 1. So it does not affect the actual value of the function, because anything being multiplied with 1 is the same thing. But we have to convert this entire function into something that the limit can be applied upon, and this is one of those ways. You multiply the numerator and the denominator with the conjugate of the numerator. Okay, so, and in some cases you have to multiply it with the conjugate of the denominator. It depends on which one it's being more complex here, right? Because this simple h over here, you cannot do anything with it, right? But the numerator is a very intricate function, this x plus h under root minus under root x, right? So you multiply the function with this the conjugate of this numerator, right? If this was in the denominator and h was in the numerator, you would still multiply it with this particular expression, because this is the more complex function. So once you multiply it, you can see that anything being multiplied with the conjugate, you can apply the property, the algebraic identity, right? So basically, if you treat x plus h over here as a, and if you treat under root x over here as b, so this is a minus b, right? And again, since this expression over here is a minus b, this expression over here is a plus b, right? And that is equal to a square minus b square, and that is what we've done over here, right? And the denominator is just simple multiplication. Okay, now once you have this, you must simplify the numerator. Okay, and obviously you can cancel out this under root sign with this 2. You can cancel out this under root sign with this 2 as well, and you're just left with this. And this x can be cancelled with this negative x, and eventually you're just left with this h, which will be cancelled out with the h in the denominator, right? Right, so h over h cancel out, and you're left with this. And now when you apply the limit of h approaches 0, you're left with this. This is equal to 1 over 2 into under root x, which is not equal to 0 by 0. So you found the true limit of this function by using the algebraic conjugate.